my name is Shane Smith, and I'm a senior color engineer at DreamWorks Animation. I know it's late in the day, and I'm the one holding you back from beer, so I'll try to keep it engaging. Welcome. This talk discusses the color journey taken on the Wild robot, starting back in late 2022. Firstly, a recap of the CIE UV chromaticity diagram as it represents the range of all the colors that we can see. You can see 3 gamut triangles represented here, the sRGB triangle in red, the P3 triangle in blue, and the ACEScg triangle in green. And on the Wild robot, careful thought went into the choice of color gamuts to use for rendering and display targets. What is P3? P3 is an RGB color space used in digital cinema and just recently turned 20 years old. How does P3 differ to sRGB? You can see that the blue primary is shared. However, the green and red primaries are closer to the edge of the horseshoe shape, also known as the spectral locus. Fortunately, P3 coverage is widely available. For us, it was on studio monitors as well as cinema projectors. So why use a wide color gamut? Well, the cinema and HDR deliverables already use P3, and by going to a wide gamut, it's also future-proofing. Well, what about rendering? For rendering, ACEScg was chosen, knowing that future displays will have coverage beyond P3, and it's a space specifically intended for computer graphics work that leads to renders that require less artist intervention, in contrast to sRGB renders that can lead to results that are not expected and can be more saturated than they should be. The Digital Cinema Initiative, or DCI, have formally produced specifications for cinema, which were standardized by the Society of Motion Picture and Television Engineers, or SMPTE. Unfortunately, there's no equivalent standard for P3 in computer graphics. Apple's display P3 is the closest target using the P3 primaries, the D65 white point, and the sRGB transfer function. You'll see in the diagram that DCI P3 uses a different white point. It's a greener white point. However, D65 approximates a 6500 Kelvin color temperature and makes more sense for computer graphics. Ideally, as light used in dimly lit artist desk environments uses the same color temperature rather than the completely dark cinema environment. D65 is also used as the white point for HDR deliverables. So on Wild Robot, we chose to use P3 D65, both at the artist desk environment and in the projection environment. And the Wild Robot was a good candidate feature film to take advantage of the wide color gamut workflow. The design was a hand-painted aesthetic, and the color workflow unlocked further potential. It had art that heavily utilized rich and saturated color palettes consisting of forest greens, cyan-emissive lights on the robot character Roz, and pastel skies. These colors found accurate translation in P3 that is much more impactful. And this was simply not possible in an sRGB workflow. The Academy Color Encoding System, or ACES, served as the color foundation, and version 1.2 was used. With the project's timeline, ACES version 2 is still in development and a bit too early to adopt. However, we do have planned upcoming adoption. OCIO v1 configs were also used due to some digital content creation software constraints. ACES includes support for a wide range of target displays, And by displaying in P3 and rendering in ACEScg, it ensured artists had access to a sufficiently wide range of colors. Some custom outputs were required to achieve compatibility, such as the desktop P3 D65 target and another HDR display that had a target luminance of 600 candelas per meter squared. Open source projects were critical in achieving their creative vision. OpenColorIO applied the ACES color workflow and aided in controlling components of the color workflow. OpenImageIO was used for texture file conversion and to embed ICC profiles in still images. OpenEXR allowed the storage of ACEScg Wide Color Gamut image data, and MoonRay produced ACEScg renders. The International Color Consortium, or ICC, color management bridged workflows not managed by OpenColorIO. The wild robot production included hybrid working, where at times only sRGB displays were available at home for approximate color viewing before viewing in the more accurate environment on campus in P3. ICC color management allows for an operating system ICC profile based on your display used. And for example, you have an image with an embedded P3 ICC profile, and then the operating system can perform a color conversion if it's required. This allowed the art department to collaborate and to see consistent color. It also provided a color-managed workflow for marketing purposes. The Chrome web browser provided a consistent viewing environment across platforms with Studio Web Tools. And the art department authored images using a display-referred workflow, which is to say they painted the value for direct display. And it differs elsewhere in the pipeline where linear-to-light images are used together with a non-destructive viewing transform. For the art department, early work had already started in sRGB, and we needed to transition to P3 D65 in order to take advantage of the wider color gamut available. And this required the batch conversion of images where possible, and in some cases, manual conversions. You can see here some of the rich artwork serving as sort of the input into the process. And the art and production design teams were good allies and got behind why we were making the change and embraced the workflow for visual development. P3 was specifically chosen in order to stay true to natural environments and to work with colors that could actually be seen on the display. Textures required modernization as 8-bit integer gamma encoded texture files were insufficient. You can see an example here illustrating severe banding. So more gradation is required and switch to using 16-bit half-float scene linear encoded texture files. In order to stay true to the natural environments, we considered this black line and what's known as pointers gamut. And that represents all of the real-world surface colors. Again, looking at the smaller sRGB triangle, you get around 81% coverage of pointers gamut, whereas P3 provides over 93%. So surface colors and matte paintings were restricted to P3. It unlocked further aesthetic potential, and these were physically colors that you could see on the display. Within OpenColorIO, there is the color picking role, and this also aided in the effort of restricting surface colors. However, not all DCCs support that color picking role. And in some cases, there needed to be a physical limit on colors that could be picked. and this could only be achieved by limiting the working color space. Another example of where the OCIO color picking role is beneficial is, for example, if you'd like to pick a color under a gamma transfer function instead of in a scene linear working color space. So this is a simulated example image from a final render. As unfortunately the projector here, I can't show you an accurate P3 representation, but this tries to give you a sense of P3 unlocking a wider color palette and that aesthetic potential. Effects, lighting, and compositing work was in ACEScg and was not constrained. And this resulted in heightened emotion when experiencing the more saturated colors. Looking at the enlarged chromaticity plot, you can see for this butterfly image that the yellow, orange, and red values are extending beyond P3 into the largest AP1 gamut triangle. And for the forest image here, the greens, the cyan emissive lights, and the pastel skies from the rich and saturated color palette originally authored by Art. And similarly, in the enlarged UV chromaticity plot, you can see the blue, cyans, and greens again beyond P3 and in the largest AP1 gamut triangle. And this was a true interdisciplinary effort and intersected production, technology, and hardware. New monitor calibration presets were required alongside existing presets, as well as projector macros. These two images give you a sense of those representative environments from the artist desk and the projection environment. There were also adjustments that we had to account for between these two environments, as in ACES version 1.2, there's surround compensation for the dimly lit artist environment, and that needed to be accounted for. We worked with an editorial video monitor manufacturer to provide new monitors, as the previous editorial displays didn't support P3, and to provide it to the specification that we required. And that helped to provide an overall more accurate editorial viewing experience. Utilizing the display hardware, technology, and production departments worked to prototype the workflow. And the look of picture served as the prototype effort. For example, there were some refinements made, including which transfer function we would end up with in P3. We also took the opportunity to align to the ACES SDR target of 100 candelas per meter squared luminance. We needed to support a mix of workflows, as some artists were not in Wide Color Gamut, as well as other projects at the studio using the existing color pipeline. And that impacted the calibrations, as I mentioned, and how production staff interacted with the projector and controlling sessions in the projection environment, and as well as in the viewing tools. In terms of ironing out an end-to-end workflow in the prototyping stage, it took around 6 months, from starting work in late 2022 to official adoption on the show in May of 2023. And due to the numerical changes between the narrow color gamut of sRGB and the wide color gamut of ACEScg, some artists need to rework their mental color model. Said another way, by shifting to a wider color gamut, more room needs to be made for all of those color values, and previous sRGB values are now smaller by comparison. It is also perhaps more common in sRGB to push values to the saturated maximum, as the end result is a color that is not too saturated. However, in working in wider color gamuts, finer control is required. The workflow allowed for a plethora of deliverables, including the theatrical formats, from standard to a wide range of premium theatrical formats, as well as SDR and HDR home entertainment versions. An added benefit of the workflow is an ACES AP0 EXR archival output. And the success of Wide Color Gamut on the World Robot drove a studio-wide creative decision to move forward with the color workflow on future productions. And this was a collective decision reached across our VFX supervision team. I'd like to thank you for joining. I also have this QR code for future or upcoming talks from DreamWorks at SIGGRAPH. Thank you.